Hi everyone. Today I'm going to tell you about type-safe tools and patterns for full-stack projects, or how I like to call it, how TypeScript helps us sleep better at night. And before we begin, I want to tell you a story about the worst birthday party I ever attended. So, just as you know, I was working with a team in Los Angeles, and that's a 9 hours difference. So, in my evening, I received a PR comment. I looked at the change, tested it, pushed it, and it was merged to main. Unfortunately, and this was something I didn't know because I closed my laptop and went to the birthday party, it was also merged to production instead of going to dev. So, you know, I'm there 1 hour later, I'm eating my cake, and I received this message. So, obviously on my phone. So obviously you can expect what was my expression. I look something like that. And I'm like, that's not good. So we are in the party, people are drinking, talking, and I'm this guy on my phone trying to figure out what was wrong. And I was trying different approaches. That didn't work, although I was thinking it would work. And you know, it was a small thing, but I felt bad because you know your code, all of you are good engineers here, and it's a very bad experience when something like this happens because we cannot control it, or at least we feel bad when this happens. And you know, in the end, it was a small thing. So this was this piece of code. It wasn't exactly that, but it was something very close to. So you can probably see what was the reason, right? So the secret API key wasn't set when it was merged to production. And some of you would say, why wasn't it validated, Bart? And I would say, shh, no one likes smart asses, right? But if you were thinking that, you are right, it should have been validated. But in the end, maybe it wouldn't cover it wouldn't cover our solution because it can still fail during runtime. Server will not start, so it must be rolled back. And we will be notified only after it happened. So in my mind, we should go into a better approaches. We should know before our code lands into the server. We should know before that something is wrong. And this is what I was, that day, I decided that I need to find an approach which will help me with that. And of course, one of them is no deploys on Friday. That would save me. But it didn't. So I believe that if you made a mistake like that, and probably you did some sort of mistake like this, I don't think that it's because you are stupid or you are bad at being engineers. I think it's just because the projects are complex, and we are just monkeys writing code. So we need something else. We need a second brain which will help us. And I believe that this brain is already there. It can be a type system. It can be there, and it can help us. And I'm going to explain you how. But before that, that's about me. So my name is Bart. I'm a tech lead at Quantiva. We are a small software house doing very weird and not very typical problems. So the small projects, we help our clients with their unusual needs. And because I'm a tech lead, I'm into communication and creating environments for engineers. That's much harder than writing code. So my latest interesting book which I was reading is called Crucial Conversations. If you know it, just find me after the talk and we can have a chat about it. And of course, I'm a role-playing games geek in my free time. You can visit Dobre Rzuty. It's a YouTube channel where I record some actual plays. But anyhow, let's go back into the presentation. And I know that some of you don't know TypeScript, or maybe you don't know TypeScript and you're afraid, and you shouldn't be. No deep TypeScript knowledge is required. So you're okay, you're covered. Let's start. Let's say that we have a task and we receive this user story. So as a customer, I want to track my payment status and be notified when payment is finished. So let's start building a solution to this. As good engineers, we should start with our design and architecture. So this is the design I did, and I'm not a good engineer, so it's a very good design. But anyhow, we'll be building a we'll be building a webhook, which we have a payment provider. I picked Stripe. There's a webhook that will receive a change in payment status and will write things into the database. So we have this architecture, and now what? So now it's the first tool I would like to introduce you to, which is called AWS CDK, or Cloud Development Kit. And it's very similar to Terraform. So you can define your infrastructure as a code, and it uses high-level constructs, which you can, with some good defaults, and they are optimized for general use cases. So they will be used to build AWS resources. It will in the end produce CloudFormation, CloudFormation template that will be built by CloudFormation, so you can have a predictable deployments with rollbacks and so on. And the most important thing for this whole presentation is that it supports TypeScript, and that we will use in a second. And for those of you who are more into like visual diagrams, this is how it works. You have your application. There are multiple stacks, which are CloudFormation things. Then you have your constructs. Then you build, inside you define your resources. Then it produces a CloudFormation template. It will be built with AWS CloudFormation and then deployed. So to give you a quick example, this is a CSV files processor architecture. So we'll be looking at this SQS queue, and we'll see how to build a queue. So here's how you define it. Extremely easy. You take SQS library from AWS, and you define a new queue. So then, with some additional glue code, you run yarn CDK deploy, you'll see the status, and in the end, you'll have an output of an actual queue being deployed to AWS. And here it is. I changed it slightly, but here it is. OK. So as you can see, CDK transforms your TypeScript code, and it produces architecture resources. And I think that this is truly amazing, because now all of you can be like really full-stack developers with knowing only one language, which is TypeScript. So now you can also be DevOps if you were web developers in the past. Let's go back to our simple architecture. So we have this payment provider, we have a webhook, and we'll be building the webhook part. Let's start with AWS Lambda. So this is a code for creating a stack. You have this class, you extend, and we will be adding the resources code in where the comment is. And this is how the Lambda webhook looks like. So we have a Node.js function. We define it, provide some information, some environments, and in the end, we attach or add a function URL. So it can be an actual webhook, and it can take information. From outside. So with the new Lambdas, you don't require API gateway, so it's really cool. But anyhow, so now we have this defined as a file. So now we need a handler. So what we will do, here's an example. So you need an entry point, which will be a handler. But if you don't provide it, if you just do .handler, it will automatically understand that this is a handler for this resource. And then it will be bundled with ES-build. So you don't have to create a new package. You don't have to define package JSON. It will all understand what kind of things it needs, and it will be bundled and deployed. So here's a webhook example. So we are starting to write it. It's just a handler, and we'll be adding payment provider code. So here I'm creating a Stripe client, and now you'll see a first thing which is interesting. So the first variable is an API key, which needs to be provided, and now you have a problem because it can be undefined, and this function requires it to be string, and that's a good information. We don't know if it's a string or if it even exists. So, what can we do now? What if we know the types? And we can easily know the types because we can define what's inside the process env. So it will look something like this. It's a small hack, but I can override the process env, and I can define my variables. Now, when I try to use it, I know that those things exist. Although, not really, because I just defined them. They might not exist. So what if we could share the types? And we can very easily do it. So instead of defining them, I'm exporting them as a type. And then inside my architecture file, I can import the type. So I'm not importing the code. I'm just importing the type. And I can use it. So now we have a contract between my infrastructure and my handler. And I know what kind of data I'm expecting on both sides. And I call it a huge success, because now if someone on Friday evening misspell a environment variable, compiler will tell him or them that something is wrong. And here's an example usage. So this is your app definition in CDK. This will be used to run it. So yeah, and the good part about this is that I'm still reading some secrets from somewhere, but now this will happen during a build time. So I can use a library like nvalid, and I know that it's type safe, it's validated, it will fail during build time, so at least it won't be deployed. So I call it a huge success. But as you can see, with the validation part, I think it's a second important piece in this presentation and this approach of building scalable application. So what if we cannot trust the input, if it's like from outside world and we don't know what it is? And I'm going to show you with an example. So let's go back to our original task. And you see that let's say that we already resolved the payment status thing. And now we want to notify our customer. So we'll be sending an email. And we'll be sending an email to an SQSQ. So here's an example. We have a function called send email. And we define properties for email that we need. Those parameters will be passed inside the message, and they will be JSON stringify. So in the end, I have params which I know, and then I'm transforming into a blob, which is just a lot of text. And then this is on the handler side. So there was a producer, now we have a consumer, and I'm parsing the body. And I already know that we have email params, right? And I'm importing them. But here we have a problem, because whenever I see this line, I'm slightly worried, because what if it fails? What if it's missing a value? Or where do we have try-catch? This may explode, and we don't want this to explode. So now, this is the worst thing that can happen. And you probably received emails like this that someone forgot to add a variable. And if something fails on the website, that's correct. But if you get an email like that, it's not something you'd like to talk with your boss, right? So I'm going to tell you a little bit about JavaScript development cycle, for me at least. So we have a new library, in this case CDK. And I know that it's a safe environment. I don't have to validate, because I already showing the types. Then I'm getting this. So what is the answer? I need to find a new library. And this is what we'll be doing. We'll be looking at a library called Zod, which is a TypeScript first schema validation with static type inference. And the static type inference is something which is interesting to us. OK, what does it all mean? So we have this type, right, for our email. And we know that it's sort of like a contract. We need those information to send this email. And we also need to validate this information. But the truth is actually inside the type. So we don't need to validate. We know what kind of type we need. So with Zod, we can create an object like this. So email params will now be z.object. You have a string. We have an enum. We have a number. And a cool part about this is that when I use it inside my send email function, I can infer the type. So as you can see, it will infer exactly the correct type. So now I have validation and type information in one place. I don't have to write it twice. And this can help to glue this unsafe outside world with your safe type system and safe type environment. OK, so I'm going to show you a couple of things that Zod can do and how it relates to TypeScript. So we could have a node, which might be optional. It might be there or not. So how we can do it with Zod? We can define it as a string.optional. We can have a payment information, because we want to display inside the email the card number or bank account number or some sort of information. So we have this union of, it can be two different things. And with Zod, we can do the same thing. We can define a union, which is two objects. And it also can be a discriminated union if you want to use it in this context. OK, but Zod is not only about types, it's also about validation, like any other validation library. So email can be email, so we'll be checking if it's actually an email. We can trim the white space from the name, and the amount should be greater than equal 0. And as you can see, when I parse it, it's nicely validated. It either fails, or I know exactly what I have. So yay. And in the end, why it is worth looking at Zod? I think it's a developer-friendly tool. You have to write types once, and this is important for me. Also, it was designed with like functional programming in mind, sort of. So it is immutable and type first and all of this good stuff. And you can easily chain it. You can have your validation in many different files, and you can then compose it into nice object which will define your validation. I think, so for example, compared to Joy, which is also an very famous or popular library, you don't have to write types twice, and you can still operate in this type area. But for example, if you are using Yap, I think in the beta version, it actually took some ideas from Zod, or maybe they came up with them. But Yap will be very similar to Zod. So if you're already using Yap, you'll have all this goodness there. But if not, maybe it's worth looking at Zod. OK, so the last piece, we'll be looking at so I'm a customer, right? So we saved the information into our database. We send an email to our customer. And now a customer wants to see and track their payment status. So probably all of you here are web developers, and web developers are dealing with APIs. And we can use the same strategy when building our APIs. So instead of having an API, we can have a type-safe API. And here we have this guy. So you know what's coming. We need to find a new library. And there is a library to that, which is called TRPC. It's defined as end-to-end type-safe API made easy. And what does it mean? And I'm going to show you a quick presentation to show you what TRPC approach can bring to you. OK, so we have a server written with TRPC, and we have an app router, and we have one query, which is one endpoint /hello. Then we defined an input, which will be parameters coming to this endpoint. It will be a text. And then we write a resolver, very similar to GraphQL, if anyone wrote GraphQL servers. So we are taking input, and then we are returning a text with hello. And now let's write a client. So as you can see, first we import a type from the server. So because we only import the type, we are not importing any code into our browser client, or like any client we are writing. We're just importing the type definition, so it will be gone during the runtime. And now, when I do it, and I define the client, as soon as I start, I know that we have a query there. And when I start doing it, we'll see that it has an information what kind of queries or endpoints are inside. And we have an autocomplete, so I'm pressing tab. Now I'm starting with T. And you will see that it will recommend me text, because the text was returned by the server. So, you know, it's there. And I can pass it, and then I'll know that the result will have a text inside. So what happens if I change the text, because text seems weird for an input, and make it a name? So as you can see, we see a type error inside input.text, and when we pass it in the client. So inside this code, we now see an error inside our editor, which is very neat, because we can just change those things. So we know it's a name, and we know it's a name. Done. So TRPC, what is it? As I was saying, it's a type safe. We have type safety and auto-completion on the client. So all those things I shown you. So there's no code generation, no runtime bloats. You don't have any dedicated build pipelines. It's just TypeScript. You just share types between your projects. So if everything is in TypeScript, you can share those types definition and treat them as contracts between different layers of your stack. It has 0 dependencies, so it's very tiny. It supports request batching, which is very nice when you're doing a lot of requests. It will batch it into one bigger one, so that's neat. It is well tested and production ready. We used it in production, so highly recommended. And you can easily add it to your existing projects. So you just do /trpc and you use it you just add it to your project, and you can use all of this TRPC stuff. It's a batteries included framework, so you can use it with React, you can use it with Next.js, Express, Fastify. I even saw Remix. I don't know how it works, but there is an adapter for it. And if you're into this stuff, it also supports the subscriptions. So it's a nice framework which is compared to GraphQL. And I even say that it is like GraphQL, but using power of shared TypeScript code. Because in the past, we used a lot of GraphQL, and GraphQL already generates code or types. But now, you don't have to generate anything. You just write everything in one language. So that's very neat. And that was me when I discovered TRPC. GraphQL is long gone. So of course, GraphQL has some good parts, but in the end, TRPC is something which I will use. And I want to show you a couple more examples, just that you know that it covers all of those needs that you have. So for example, when I want to have a query for payments, I can query a list of payments, and I do it by creating a resolver which will return a list. So here we are using Prisma database. That's another missing piece in this whole thing. And then you can easily use it with your React code. So we have a React component called payments. And here you see that there's a TRPC use query. It will load the data from your server. And it has all of this information that you would require. So you know that it's loading, you know the data, you know the type of the data, everything is type checked, so you know what you're getting. And the cool part about this is that the use query is a thin wrapper on top of React query. I don't know if you used it, but I really love the library. So if you haven't, check it out. React query is great. Cool. So here's a mutation. So how you post your data to your server or put your data to your server. So here we have an input with name, amount, and we can create a payment. I don't know if creating a payment on the backend is a good idea like that, but that's just an example. And here you will see a React code for creating a payment. So we are using this thing called use mutation. Then we mutate. We know that it's loading. We know errors. Oh, and errors are important. It has a defined definition for errors. So error would look something like this, and it's standardized. And you can extend it, and you can play with it. So in the end, I think TRPC is a great approach for creating those servers. And one comment that I found on the internet, which I really liked, was that apart from the type safety, it is very simple, and it fit nicely how you work. I even feel that it's like Prisma, but for your API. So if you used Prisma and you know how good it is for using your database, then you know how TRPC may work on the front end. So now everything is fits nicely how you operate when writing your code. Because we want everything to be transparent, but we want to understand it. And yeah, TRPC is even more. So it has nice support for permissions. It has nice support for different backends. It can do context, like all of the things that you expect from the server-side client. Cool. So just going back to the beginning of our talk. As I was saying, this approach with those free libraries I shown you, is the idea of the second brain. So now, because everything is type checked and everything that you are using will fail during the build time, or you will be notified inside your editor, you don't have to think about it. You don't have to be careful. You will be notified, and you can use your time to write code to solve problems, and you don't have to worry that you forget something because you have this covered with your type system. So in the end, those are the 3 things that if you want from this talk, just remember those 3 libraries: CDK, infrastructure tool; Zod, validation with type inference; and TRPC, type-safe API framework. If you want more, there's a couple more libraries which I use. So Prisma, Nexus, Neverthrow, and Valid, but that's another thing. So that's the end. Any questions?
Yeah, we've got questions. And the first question is, how would TypeScript save you from process.env.secret being undefined?
So if we go back to the, I can go there. That would be a long scrolling, but almost. Let's wait. I'm going to show you an example because it's much better than just explaining it. Cool. So here, TypeScript will not save me in any way, but here, using this library called envalid, I know that it's either there or it will throw an error. And because this thing happens during the build time, it will throw an error straight away. So it will start building, and I'm gonna have an information that the environment variable is not there. So if it's not there, I'll know, and then I can pass it into my whole infrastructure, because here the code here is my infrastructure. So I don't have to. So from this point on, I know that it exists, and I know it was validated. And this is like an entry point from this unsafe word. And then in many different places, I know that it always exists.
OK, thanks. And how is TRPC solving the problem with overfetching?
OK. I think it's very similar to GraphQL, but a little bit different. So I don't think it is solving the overfetching problem because you cannot define, or other way around. In our case, we were usually doing a lot of small endpoints, and those small endpoints were serving special needs of the page or the use case that we needed to serve. So what I'm trying to say and I'm going to go back, once again scrolling. You probably saw there was this, when I was returning data from my API, I was just selecting what kind of data I want. So in case of payment, I wasn't. I was only including what I wanted. So for example, for this payments example, I only need, for this page, I only need this much data. And if I need more data in different page, I can always create a new endpoint, or I can define it differently. So I think this would be the way how TRPC helps with that. And I feel that it's not really, so because the code is very cheap in this example, you can create as many endpoints as you want, and this way you can solve it. So you can use your endpoints for your application instead of creating a generic API that everyone could use. So here probably you can see a problem. This is not a great tool to create APIs for other teams to use. This is a great tool if you have one team which works both on the front end and back end and can change both of those things at once. So yeah, I think that's the answer.
Well, thank you.